All right, what I want you to do is first of all, make sure you're looking at test version B, that's the one you have. And I want you to go and fix anything that's wrong, meaning you can rewrite it, you can write it on another piece of paper. Um, but somehow I want to be able to see that you went through and did some of this thinking. So write an equation of a line. You need some things to write an equation of a line. You need a slope and y-intercept, or slope and a point. It looks like the y-intercept might be hard to read, so we're going to have to use the point slope formula, which if you were to look on your formula sheet, looks like y minus y1 equals m times x minus x1. The slope, remember, is just the rise over the run. The change in y's over the change in x's. So first of all, it's negative. It looks like the line goes from 1300 down to 800, which is a change of 500. And it goes from 10 to 20, which is a change of 10. Simplify this, the slope is a negative 50. The question asks, what does the slope mean? Well, that's $50 over 1 month. So the slope must mean it drops. This interest loan drops $50 per month. Now let's figure out the equation. Y minus, you can use either one of these points. I'm going to use the 2800 just because the numbers aren't as big. The slope is a negative 50 times x minus 20. Let's simplify it. Y minus 800 when you distribute equals a negative 50x plus 1,000, I think. Add 800, add 800. Your final equation should be y equals negative 50x plus 1,800. Number 2 is a constant function. It's a horizontal line. And all constant functions we talked about have the f of x equal to some value that doesn't change. If we count by 2, 4, 6, 8, 10, 12, it looks like this equation is simply f of x equals 6. There's a zero slope, so the slope means it stays at 6 miles per hour. Take a look at number 3. Solving the system, eventually we're looking for a point of intersection. This looks like it's close to eliminating if my y's had a negative 3 on top. So I'm going to multiply through everything by a 3 so that my y's will eliminate. So 3 times 3x is 9x minus 3y equals 21. Sometimes you might consider multiplying both of them. In this instance, you don't have to. So we're going to just keep 2x plus 3y equals 1. Since number 4 is extra credit, you might want to consider multiplying both of them. My y's eliminate. I have 11x equal to 22. X equals 2. So there's my x point. Where do I get my y from? I can plug it into any equation. I'll just put it here. 2 times 2 plus 3y equals 1. I'm going to subtract 4 from both sides. Y equals a negative 3. Y equals a negative 1. 2 comma negative 1 is my solution. Numbers 5, 6, 7. Really, all you need to do, since we are talking about linears, is check out the slope and check out the y-intercepts. because all three of the equations for 5, 6, and 7 are written in slope-intercept form. The first thing I'm going to do is take a look at the y-intercepts. Looks like the scales are all by 2, so be careful. So on A, it looks like the y-intercept's at 1, and it's a negative slope. For B, it looks like we're at a negative 1 and positive slope. And C, it looks like we're at 3 and a negative slope. Is that enough for us to match it up? Here's my B's. Since these are all different, I think we should be able to match this up. Which of these equations has a B of 1? I think that's number 7. Which has a B of a negative 1? 6. And which has a y-intercept of 3? 5. All right, parent functions. We went over 4 major ones: constants, linear, absolute value, and quadratic. Number 8 is a quadratic, so it should be a parabola. The parent function is simply f of x equals x squared. That's a parabola with the vertex at 0, 0. Goes up 1 over 1. It goes up 4 over 2 is the regular width without a stretch or a shrink. Now, when we talk about transformations, that's when we need to look at our A, H, and K. Here's my stretch, here's my left and right, and here's my up and down. The function they gave us looks like this. It's something smushed up to the x squared. That would be our A, so it's a stretch of 2. It's going to get skinnier. So instead of going up 1 over 1, it's going to go up 2 over 1 and just end up being a skinnier parabola. Parent function for number 9 is the absolute value of x, which is a v of perfect diagonal. Again, it looks like it's just the a that changed, so it should be a stretch of 3. And what does the negative tell us? It's a reflection. So it should flip. So it's going to be skinnier, so it's going to go up 3 over 1 this time, up 3 over 1, because it's stretching 3 over 1, and it's a reflection. All right, I'm going to press pause, and I'm going to enter this into Desmos so we can take a look at what that might look like. All right, so I've gone and filled in my Desmos, and then I've used the, remember y sub 1 is the squiggly line m x sub 1 plus b. Here's my m, here's my b, and there's my correlation coefficient, which looks like a strong positive. So if I was going to write this as a linear regression, y equals mx plus b, instead of writing m, I'm going to write 24. And instead of writing b, it looks like 16.3 rounded. And I'd agree that this looks like it hits about 16.3. Remember on Desmos, why mine might look different than yours is because I changed the view with the wrench. I changed the y, the x, just to view from 0 to 5 because I looked at my domain. 0 was the smallest and 2.5 was the biggest, but I went up to 5 so I could see more. And then my y I did from 0 to 70. Don't forget to change that so it makes sense. All right, let's finish this up. Taking a look at 11 and 12. This looks like a quadratic equation, and this looks like an absolute value. All we need to do now is decide what transformations happen so that we can change. I think it's hard to tell the width, so I'm going to assume it's not a stretch. It simply moved from its parent position at 0, 0, up 1, 2, 3, 4. Up and down is changing the k on the outside. So I'm taking the parent function and adding 4. There's the new equation. Domain and range. Domain is your x's. Range is your y's. The domain, eventually, if this gets wide enough, all of the x's will be used. So the domain for functions is almost always all reals. The range, if we take a look, all of the y's will not be part of this graph. None of these are involved in the graph. Only from 4 up, if we stretched it further over, it would touch the graph. So these are all the y's that are greater than or equal to 4. F of x, it looks like the only thing on here is here's the parent, same width, but it's reflected. That means that there must have been a negative number, and if the width stayed the same, we'll say it's a negative 1 times the parent function. It doesn't move left or right, doesn't move up or down. The domain again is all reals because all of the x's can plug into that. But the only y's that are used are these going down. So that's all the y's that are less than or equal to 0. And then number 13 has a vertical stretch of 3 and a translation of 2 units up. Vertical stretches are A, translations are your K. So if this is the general of a quadratic equation, that should be h squared plus k. It doesn't say left or right, so there's not going to be an h. And it says a stretch of 3 and moves up 2 units. So our g of x should be 3x squared plus 2. Don't worry, unit 2 has a lot more of this. I think that's all we got. So please make sure that you've gone and corrected all of these and written the right answers and some thinking, and then fill out the graphic organizer that I handed out and hand both the test and your graphic organizer in. Thanks.